All right, hi guys. In this video, we are going to go over example 2 on page 11 of your 3B packet. Again, if you do not have a packet at home or a printer at home, please feel free to just copy along in your notes, follow along, and copy this into a notebook at home. So this is your second example of graphing a polynomial function, and we have h of x equals negative x to the fourth plus 4x squared. So the first thing that we do here is we look at the leading coefficient test. And in this one, I have a negative leading coefficient with an even degree. So even means that they are going in the same direction. Negative means I'm going down, down. So that's the picture I would draw. And then I can write it. So as x approaches negative infinity, so that's the left side, f of x is going to approach negative infinity. As x approaches infinity, f of x approaches negative infinity. So there is our end behavior, and that's all based off of the negative leading coefficient and the even degree. So I know that on the left and right ends of the polynomial, both of my arrows should be pointing down. So now that I know what's happening on the outside, I want to find out where it's going to cross the x-axis. So I'm finding the x-intercepts. So first I need to factor. So I have 0 equals negative x to the fourth plus 4x squared. Now, something that's really important to me is that I never leave it so that I have a negative leading coefficient. So I'm going to factor out that -1 first, and I'm also going to factor out x squared. So that's my GCF. Whenever the first term is negative, I always factor out a negative. So this leaves me with negative x squared, and then I've got x squared minus 4. And notice it's important that I took out that negative because now I can recognize that this is a difference of squares. So I've got negative x squared, and then x plus 2, x minus 2. Now, something that we can remember from Unit 2A is that when I have a exponent on an x, that makes that value that 0 have a multiplicity. So this here tells me that x equals 0, but it has a multiplicity of 2. And that multiplicity of 2 is coming from that exponent of 2. This one here, x plus 2 equals 0, tells me x equals -2. And then x minus 2 equals 0 tells me that x equals 2. So I have 1, 2, 3 distinct zeros, but I have 4 if I count the fact that this one has multiplicity, which makes sense because I had a degree of 4 to begin with. So now to find my y-intercept, I plug in x equals 0. So notice for the x-intercepts, I plugged in y equals 0, so that's why I did this. For y-intercept, I plug in x equals 0. So then I do -0 to the fourth plus 4 times 0 squared. And so from here, I have -0 plus 4 times 0, which is just going to be 0. So this one has a y-intercept of 0. Now, one last thing I'm going to figure out, is it even, odd, or neither? So first I have f of x equals -x to the fourth plus 4x squared. So first I'm going to plug in -x, so f of -x. Now keep in mind, if I have a -x to an even power, that makes that the same as just x to the fourth. This negative stays, so it's negative x to the fourth plus 4 times x squared. Because remember, negative x to an even power, still positive. So notice this is the same as f of x. So since f of negative x equals f of x, that makes this even. So whatever I do when I graph the function, remember, even means it is symmetrical about the y-axis. So I should be able to fold the graph in half on the y-axis, and it would be the same on either side. So that's something that can kind of help me going into the graphing, knowing what it's expected to look like. So now keep in mind, I take these zeros and I transfer them to the next page. So my zeros were 0, 2, and negative 2. And this one had a multiplicity. So I always start by graphing those. So I have 0, 2, and negative 2. So again, since I have 3 zeros, I'm going to make for 4 intervals. So I'm going to go negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. And I want to pick an x value within that interval. So between negative infinity and negative 2, I'm going to choose negative 3. Between negative 2 and 0, I'm going to choose negative 1. Between 0 and 2, I'm going to choose 1. And then between 2 and infinity, I'm going to choose 3. Now, one thing to keep in mind, this one had an end behavior of negative infinity on both sides. So somehow I should have those arrows pointing down on both sides. All right, so I'm going to go ahead and plug in these values. So negative 3, so I have negative 3 to the fourth, plus 4 times negative 3 squared. So I have negative 3 to the fourth is going to be 81 plus 4 times 9. So negative 81 plus 36 gives me negative 45. So that point is negative 3, comma, negative 45. Which makes sense because that's going negative and that's where the end behavior is supposed to be. Now if I plug in negative 1, negative 1 to the fourth is 1, so I have negative 1 plus 4 times 1. Negative 1 plus 4 is 3, so I have the point negative 1, comma 3. And that one fits on the graph, so I can plot it. Now when I plug in 1, I get negative 1 plus 4 times 1 equals 3, so I have the point 1, comma 3. Now this makes sense because keep in mind this is an even function, so it makes sense that this would be reflected. Another thing that makes sense about this is if I connect these points, the 0, so first of all, that makes it even. Second of all, the 0 had a multiplicity of 2. And keep in mind, when you have an even multiplicity, it's supposed to touch the x-axis and bounce off. Notice how this bounces off. Now, if I plug in 3, I'm going to get negative 81 plus 4 times 9, so that's negative 81 plus 36, and I get negative 45. Which makes sense because it's even, and that's reflected about the y-axis with that negative 3 comma negative 45. So these lines here should just go down like this. It has the correct end behavior. At negative 2 and 2, it goes through the x-axis, and those have a multiplicity of 1, which makes sense. Odd multiplicity, it goes through. At 0, it bounces off, which makes sense because that one has a multiplicity of 2. If I look at this graph, I can visibly see that it comes out as an even function because it is reflected about the y-axis. So these are all different things that you can check to make sure that you're graphing correctly. One thing that is super, super important is that, again, you only touch the x-axis at the zeros that you found via factoring. So hopefully these are helpful when you go into your Desmos practice for this week. This is exactly the kind of process you want to do, but you're going to plot it online by sketching it on Desmos.